I changed the background because I want you guys to be able to see the graphs, okay? All right. So this first box is going to give you a story. I'm going to give you the story of sine, cosine, and tangent. But it's the same theme over and over again. You don't necessarily need to copy all of this down, but I'm going to ask you some questions along the way to make sure you're staying with the story, okay? So let's begin by taking a look at this first picture that you see here. Can someone tell me what function am I looking at right there? Anybody? Just shout it out. The sine of x, right? This is the function f of x is equal to the sine of x. All right? How do I know that? Because I have some of those critical points on there, right? So everybody believes that's a function because it passes what? The vertical line test. However, is it a one-to-one function? No, it's not one-to-one because it does not pass the horizontal line test, right? But we did something, right, to talk about its inverse. What did we do on Thursday? What did we decide we did? We restricted its domain, right? And what did we restrict its domain to? Awesome, KK. Very negative pi over 2 to positive pi. So what I'm going to do is if I drew a box around that right there and only talked about that box, and if I drew it a little bit better, right? If I restrict its domain between negative pi over 2 and positive pi over 2, then all of a sudden that function becomes a one-to-one function, and therefore it has an inverse. You guys still following the story? Okay, good. Now take those three critical points, okay? Those points are negative pi over 2, negative 1, 0, 0, and pi over 2, 1. How do I get this graph over here? What is this graph of? This is the graph of what? F of x equals sine inverse of x. So take a look at this point. Negative pi over 2, negative 1. Now look at this point over here. Negative 1, negative pi over 2. What happened? We just switched x and y values, right? Notice 0, 0. If I switch it, I get 0, 0. Stays the same. If I have pi over 2, comma 1, I'm now going to have 1, comma pi over 2. Okay? So this is the graph of the inverse sine of x. And that allows me to solve problems when I am graphing the inverse sine function. It tells me that it only lives between negative pi over 2 and positive pi over 2 for the sine function. So it's positive in quadrant 1, it's negative in quadrant 4. This represents quadrant 4, and this represents quadrant number 1. And that was basically what we did on Thursday. Everybody caught up to speed? Okay, so again, we start with the trig function. We restrict the domain. We invert the x's and the y's, and we get this picture when we draw inverse sine function to solve the problems that involve that. You guys good with me so far? Guess where this story is going to go for the cosine curve? It's the exact same story, okay? It's the exact same story told in the same way, except we have a phase shift, okay? So I'll begin. What function are we looking at right here? F of x is equal to the cosine curve, right? This is the cosine of x. I have a couple of key points there, okay? It's a function because it passes the vertical line test. Is it a one-to-one function? No. So does anybody see a spot where we could maybe restrict its domain to make it a one-to-one function? Yeah, from 0 all the way to what? To pi. There we go. If I just look inside that box, if I just look from 0, less than or equal to theta, less than or equal to pi, I now have a one-to-one function, right? Okay. Therefore, the inverse cosine has to only exist on a restricted domain, right? Now take these three key points. Take 0, 1, invert it, flip the x for y. What point do you get? You get 1, comma 0. Take the point pi over 2, 0. Flip x and y. What do you get? 0 pi over 2. Take this point over here. Pi negative 1. Flip it. What do you get? Ah, so what graph am I looking at now, ladies and gentlemen? F of x is now equal to the inverse cosine of x, okay? So it looks just like the sine curve, except that. So now, let's break this back up. What does this represent? What quadrant is this? That's still quadrant 1, right? What quadrant is this? That's quadrant 2. So therefore, the inverse cosine lives on a restricted domain between 0 and pi. Oh. Positive in quadrant 1, negative in quadrant 2. Do you guys see this story? Is that making sense to you? Yeah? You guys have never seen the tangent function before, right? It looks crazy scary, right? Let me show you what it looks like really quick. I have all these great trig functions lined up for you to go. Here's a picture of the tangent function. Whole shenanigans. Look at this thing. It goes on and on. Like, I'll zoom way in, I'll zoom way out. This is a dancing-esque function, okay? This is obviously freaky looking, right? But you can definitely see that it's definitely periodic, right? The same thing happens over and over on certain intervals. You guys still with me on the story? Okay? So don't worry about this. We're going to come back to that. Let's actually figure out. We're only going to graph a certain interval, so stay with me on this story. You might want to copy this part down. Okay? So I'm going to draw the same exact picture that I would draw for my other functions as well. Okay? I'm going to do pi over 2. I'm going to do pi. I'm going to do 3 pi over 2. And I'm going to do 2 pi. Now let me even go back a little bit to negative pi over 2. Okay? Again, this stuff represents, if I draw all this, it represents quadrant number 1. If I do all of this, it represents quadrant number 2. If I draw all of this, it represents quadrant number 3. And if I draw all this, it still represents quadrant number 4. Okay? And then, what would this one be if I back up 1? What's that going to be? Quadrant 4. Good. I'm so glad you guys see that. That's just a repeat, right? It just repeats itself. Okay. Now, if I were you, I'd have your bite size out, because I'm going to ask you some questions, okay? Have your bite size out right here, all right? Let's start with the easy one. What's the tangent of 0? The tangent of 0 is 0, so therefore 0, 0 is on the tangent curve, okay? Okay. Tangent of 0 is 0, yeah. Because it's 0 divided by 1, right? So it's 0, okay? Now, here's a really easy one. Let's take a look at pi over 4. Pi over 4 is still in quadrant 1, right? What's the tangent of pi over 4? It's 1. Very good. Okay? And let's go back. Let's go to negative pi over 4. Negative pi over 4 is just in quadrant 4, right? Swinging down, quadrant 4. What's the tangent of negative pi over 4? Negative 1. Okay, good. So this point is here as well. Now, what's the tangent of pi over 2? Remember, pi over 2 is 90 degrees. It's what? It's a radical? No. It's infinity. Right? It's undefined. It's undefined because at 90 degrees, we have the point on the unit circle, which is 0, 1, xy. So therefore, the tangent is the ratio of 1 divided by 0, infinity. So we actually have an asymptote here at pi over 2. And we have one then at negative pi over 2. Okay? So therefore, what we have is this curve. If we actually computed the tangent of every angle between negative pi over 2 and pi over 2, we get this beautiful curve. And this beautiful curve repeats itself every interval, so it would look like this. And that's where it comes from. Okay? So the one that we just did, so we're going to concentrate on this picture here. Okay? Just that one there. So you can see that if I kept repeating this picture over and over again, right, I would get something that looks like this picture here. Do you see it? Okay? So the one that we did was only this one in the middle here, right? Because after all, it repeats itself over and over again. Okay? So same story that we're going to tell over and over again. There's our tangent function. It is a function because it's defined everywhere where we exclude those asymptotes. Okay? So if I restrict the domain to make it a one-to-one function, if I restrict the domain from negative pi over 2 to positive pi over 2, strictly less than theta, strictly less than pi over 2. If I just look at this interval, if I just look at my highlighted yellow picture, is that now one-to-one function? Yes, it is, okay? So I have 3 key points. I have this point here, and that point there. I have coordinates for those 3 points. I'm going to do what? Flip their x and y, right? All right, good. So what is the F inverse Oh, sorry. Excuse me. If I want the function f of x equals the tan inverse of x, here's what I would have. Okay. Instead of the point negative pi over 4, negative 1, what would I have? I'd have negative 1, negative pi over 4. So I'd have that point. 0, 0 is still there, and then I would have 1, comma, positive pi over 4. But I would be bounded. I would be bounded between negative pi over 2 and positive pi over 2. So here's pi over 2 up here. Here's negative pi over 2 down here. And there would be asymptotes here. So my graph would look like this. Okay? I just want you to see this graph. Alright? I'll come back in a second. And I'm recording all this, but look, the inverse tangent function looks like that. It's bounded between positive and negative pi over 2. There it is, right there. And you can play with this just yourself and see. That's not the important part. The important part is this. Okay? How do I draw the picture for taking inverse tangents? What was my original domain restriction? Negative pi over 2 to pi over 2. So it's the exact same picture for sine. Right? Negative pi over 2 to pi over 2. Okay, we'll start with a basic one here. The inverse cosine of negative root 3 over 2. Okay? You have to understand what this means. This phrase means what? The angle whose cosine is negative root 3 over 2. Well, because cosine inverse is restricted between two quadrants, the first one where it's positive and the second one where it's negative, between 0 and pi, cosine inverse is restricted between those 2 points, those 2 quadrants. So what picture should I draw for this one? The one that's in quadrant 2, huh? So I am looking for, there is some angle over here. There is some angle whose cosine, which is the x value, is negative rad 3 over 2. What angle would that be? Now,
You could just look at your right side.
the unit circle would tell you, yeah.
1/2, which is 1/5.
Okay. So this is equal to 5 pi over 6. Because this says the angle whose cosine is negative rad 3 over 2. If we restrict the domain between quadrants 1 and quadrants 2, there's only one angle whose cosine is negative rad 3 over 2. And that angle is 5 pi over 6. Okay, here's what it says. You've got to be able to read this and make sense of it, right? This statement says what angle between 0 and pi has a cosine of negative 1/2. Well, it's positive in quadrant 1, it's negative in quadrant 2. Cosine is, right? That's my domain restriction. So where on the unit circle am I going to have an angle whose cosine value is negative 1/2? What angle would that be? That would be 2 pi over 3. Okay, this one says the angle whose cosine is 0. The angle whose cosine is 0. So where is the cosine value of 0 between quadrants 1 and 2? Yeah, right up, straight up top, right? So this is a value of pi over 2. Okay, here we go. The inverse tangent of radical 3. So again, this statement means what angle theta has a tangent that's equal to pi or radical 3. Remember, for inverse tangent, it's the same exact picture. Negative pi over 2 to pi over 2, except we can't obviously have pi over 2 or negative pi over 2 because there's asymptotes there. So it's positive here, it's negative here. So what quadrant should I be in? I should be in the first quadrant, right? So I'm looking for, in the first quadrant, whose tangent gives me radical 3. That means the ratio of y to x is radical 3. What angle would that be? That would equal pi over 3. Very good. Alright. The inverse tangent of negative 1. It says what angle between this domain restriction, negative pi over 2 and pi over 2, for regular tangent, right? Positive in this quadrant, negative in that quadrant. What angle tangent would be negative 1? Well, it'd have to be somewhere in quadrant 4, right? So what angle would give me a ratio of y to x that would equal -1? What angle does that have to be? No, it's not 7 pi over 4. It's negative pi over 4. The reason is because, remember, we have to stay within this domain. We are not allowed to do this. We're not allowed to swing out and back down. Right? We have to stay within our domain restriction. So our answer should be negative pi over 4. Okay, here we go. This looks like a scary problem. It's not that scary. We're going to do the cosine of the inverse tangent of 5/12. We're going to start from the inside out. We're going to work from the inside out. So that statement says this: the angle whose tangent is equal to 5/12. That's what that statement says. Now for the inverse tangent, I'm locked between negative pi over 2 and pi over 2 for a domain restriction on the tangent function. This is a positive value, so I must be somewhere in quadrant 1. So I'm going to draw a picture in quadrant 1 that clearly defines the tangent. There's semi-angle theta. What do I know about that particular picture? I know the tangent is a ratio of 5/12. So that means that this has to be a 5. That means that this has to be a 12. And this is a right triangle. And the Pythagorean theorem would tell me that the hypotenuse is 13. Right? So what do I want? I want the cosine of this picture. And the cosine is defined as the opposite to the hypotenuse. So this whole answer is just 12/13. Cotangent of the inverse sine of -1/3. Whoa, man, crazy. Okay, remember, this right here means the angle whose sine is -1/3. Okay. So for the inverse sine function, I'm locked between negative pi over 2, positive pi over 2. It's positive there, it's negative there. So how should I draw the picture? In quadrant 1 or 4? I should definitely draw the picture in quadrant 4. So here's the picture in quadrant 4. And what do I know about theta, which is right there? I know that its sine ratio is 1:3. So therefore, the sine, this has to be -1, and this has to be a 3. So therefore, by the Pythagorean theorem, I know this side happens to be 2√2, because I've done the work ahead of time. Okay? Now, what do I want? I want the cotangent of that picture. Right? The cotangent is defined as x over y, right? So that's going to be 2√2 divided by -1, which is going to be -2√2. So this, the answer to this is -2√2. Okay? Okay, here we go. Let's do the sine of the inverse tangent of 3/4. Okay, here we go. Last one, right? Tangent lives here, negative pi over 2 to positive pi over 2. It's positive in quadrant 1, negative in quadrant 2, or 4, sorry. So I'm somewhere in quadrant 1, huh? Because the tangent is positive. So I'm going to draw a picture that highlights quadrant number 1. And there's my angle theta. What do I know about that angle? I know that its tangent is 3 to 4. So therefore, this has to be 3, right? This has to be 4. Pythagorean theorem tells me that this has to be a 5, right? And I want the sine of that angle. And the sine is the opposite to the hypotenuse, so this answer is nothing more than 3/5.